differentiation question similar to earlier, okay? Now, it says, this is question 9, it's on page 329. Okay, so page 329. And that is, I think it's Keane, you're the only one with the EDCO, aren't you?
Yeah.
So, it is basically the 2012 pilot paper, okay? So, investments can increase or decrease in value. The value of a particular investment of €100 found in the following model. Phi equals 100 plus 45t minus 1.5t squared. Can anybody identify what type of equation that is and why would you call it that equation? It as a quadratic equation because of the variable t squared. Next question I'm going to ask you is it n-shaped or u-shaped?
N-shaped.
And why is it n-shaped? Minus 1.5t squared. So if you were to draw this out, it would be an n-shaped graph. And n-shaped graphs, do they contain a maximum or a minimum point? Maximum, because you can see it by the top, okay? Now, what happens is, it says, find the rate at which the value of the investment was changing. The key word there is changing, okay? So, what I'm basically going to show you now is, if you were to get your calculator, okay, and you were to enter this function onto your, just to start off with, okay, you go to mode, you go to table, okay, and you have f of x. Now f of x represents the y value. In this equation here, which letter represents the y value? Is it phi or t?
T.
Okay, so we're having a bit of a disagreement here whether it's phi or t. Okay? So usually when you're given the equations, we have y squared equals something like x squared plus 5x, let's say plus 6. Whichever letter it's on its own is the y-axis, and whichever letter there's usually more than one of on the right-hand side is the x-axis. So once again, which one would be the y-axis and which one would be the x-axis? Phi is the y-axis and t. Okay, now phi is the value of the investment in euro, and t is the time in months after investment. Now, there's one thing about what would be the starting off value for t. Could t be a negative number, for instance? Could I find out the value of the investment when t equals minus 3? Is that possible? What does t represent? Time. So t equals 3 would represent what? 3 months. Okay, because it says, you can see that it represents the time in months, this part here. Okay? So t equals 3 is 3 months. What t equals minus 3 mean?
Minus 3 months.
But that's not possible, is it? So our starting off value would be 0. Okay? Now if we read down the questions, okay, you can see that it goes up past 18 months. Okay? So what we can do is we can actually explain what's going on through our calculator in the early stages. So if I put in this formula, 100 plus 5x minus 1.5x squared, and you can see it here, just pressing these buttons here, and squared, okay? Now, your starting off point we said is t0, time equal to 0. What would you say, what would be a good ending? Anything above 18, wouldn't it? Because 18 is in the question, so let's say 24. Any number that it can fit. Now, what does step represent? Do you remember what step represents? So, you'll get the value for 0, 1, 2 months, 3 months, 4 months. If I did a step of 2, what would that mean? Every second month, 2, 4, 6, 8. So we go for a step of 1. Okay? And what you notice here is a bunch of values. Okay? So after 0 months you have €100. So what does that mean? Your initial investment is 100. And what's happening to the investment as time goes on? And then goes back down again. Okay? And you can see it's decreasing. And then all of a sudden you've lost money. Okay? Now I'm just going to double check that I've entered that. That wasn't right because I entered in. I was expecting that losing money so quickly means there's an error there. So just always double check it, okay? So it's actually 45x. Let's go again here. And this time it's a much bigger number, okay? So it goes 143.5. So you keep going up. Now tell me the minute it goes down. So we're still going up, aren't we? And then what happened there? Down. And you see the way the 436 and 436 are the same number. If you were to draw this on a graph, okay, and here it is here. Okay, so this here is a representation of the function we just saw on the board, okay? So if you were to draw this, okay, and time in months is the x-axis and investment is the y-axis, and what you can see is all your numbers here are plotted on the graph. So for example, what one will have 400 on it? 10, 400. Is the point 10, 400 on this graph?
Yeah.
There is there. And is the point, the maximum point, let's say, what was it, 15? Halfway in between 14 and 16. Now, this represents, the functions represent the graph. And it's from the graph we can understand exactly what the question means, okay? So you don't have to draw the graph in this question, but we're just treating it like, if you're given this in a business, as a business model, you could say after no months you have €100. Your investment rises, rises, rises. What's another word for rising? Increases to a point. What's this point represented as? A maximum point. It then decreases on its way down. So, the question says, find the rate at which the value of the investment was changing after 6 months. Now some people might be inclined to do this. Here's 6 months and it's worth roughly €320. Why is that not answering the question? What question would you, if to reword the question, what question did you actually answer? Does anybody know what question you answered there? If you said the answer to 6 months was €320, what question did you answer?
What's the investment worth after that?
What is the investment worth after 6 months? Not the rate at which the value of the investment was changing. That's the key thing in language, okay? So, what is change? Alright, differentiation is the maths of change, okay? So, if you have 6 months here, what you represent change by is a slope. Okay, so we can see that the slope is going diagonal right up. Is that a positive slope or a negative slope? Positive. So when you find this slope, you should be able to find out how much it's increasing by. Now, as you said earlier, we're in the differentiation section. How do you find the equation of a slope?
Differentiate once.
Differentiate once, right? So we're going to differentiate. Now what happens when you differentiate 100? 45t? 45 and 1.5t squared. You bring the t to the front, multiply it by minus 1.5, that gets you minus 3t. That's perfect. Now, this is the equation for the rate of change. Now, what else does the question ask you? The rate of change after 6 months. What variable is 6 months? T. Time. T equals 6. So it's going to be 45 minus 3 times 6, which is? 45 minus 18, which is? 27. Now, 27. Please remember what it is. It's euro. Slope is defined as rise over run, which is the y value divided by the x value. If the y value is euro and the x value is months, what do you think the slope means? Euro per month. Y value over x value. So it's going to be euro per month. Okay? Now that that's done, we go back to the original question here, which was number 2. State whether the value of the investment was increasing or decreasing after 18 months and justify your answer. What does increasing mean again? Slope is? Positive or negative? Positive. Decreasing? Negative. What's the formula for slope again? If you look at the last section? Okay, so dv dt is 45 minus 3t. Okay? So dv dt is 45 minus 3t. And what does it want me to check out? 18 months. So what do I do next? T to 18. And what happens now? 45 minus 54, which is minus 9 what though? Euro per month. So it has a context here, euro per month. Okay, so minus 9 euro per month. If we look at this on a graph, it should be occurring after the maximum has occurred. Is that the case? Is 18 after the maximum? 18 is here. I probably just need to drag it down a little bit. 18 is just after the maximum, and as predicted, it's decreasing. Happy enough with that? Okay. Next part then is, I think it's part 3. The investment was cashed in at the end of 24 months. How much was it worth at the time? Dave, you gave me advice on this earlier. Remember when I asked you for the 2 interpretations of the question? Okay, that's alright. So, what this question is the investment. So, can anybody call out the initial formula?
45 minus 3.
What's the y value? What's the part on its own?
V. Y.
V. V equals what?
100 plus 45t.
Okay, just for yourself. 100?
Plus 45t.
Alright, 100 plus 45t.
Minus 1.5 t squared.
Now, what you would have told me earlier was that the value, V, if you put in 6 months, it tells you how much the investment in total is worth after 6 months. While the other equation, which was the VDT, was 45 minus 3t. What does this one tell you again?
Change.
How much it's changing at a particular time. So we want to find out how much was it worth at the end of 24 months. So it's going to be 100 plus 45 times 24, yeah? Minus 1.5 times 24 squared. Now what would that be in the calculator? See if you can beat me to it, okay? I need to change mode to regular mode.
316.
How much?
316.
316. Say that sounds about right. Minus 1.5 times 24 squared. And 316 euro is what it's worth. Okay. I'll rewrite a question for you that would ask you to put it into 24. Okay? So, if this was, do you see the language of the question on top? That question is a equation V question. How much is it worth? If I rewrote the question like this, by how much was the investment?
Good afternoon, would all teachers please leave absent outside the door to quick announcements. The under 7.
Now, if I wrote this, by how much was the investment changing at 24 months? By how much was the investment changing at 24 months? That would be a question where you'd put 24 into the second equation, but that's not the case, okay? Yes, Peter?
Couldn't use the graph at all to...
You could draw the graph like, it's not necessary, but what I'd find from the graph is that the graph is a good way of telling what exactly is going on. Otherwise, it's just an equation on its own. So you got to remember, anytime you see a quadratic equations always have a graphical representation. So you could draw the graph, but at the end of the day, if it was after 24 months, you still have to find this slope here as it touches it at 24. You still have to find that slope there, and the only way to do that would be differentiating and putting in t equals 24. Okay guys, the next one, alright, is number 4. By how much was the investment worth when it had a maximum value? Now, at maximum values, okay, what does the first derivative represent again? What does it represent? So when you differentiate once, what does it represent?
Changing.
It represents the change. What's another word for the change? It begins with S. Slope. This is the formula for the slope at any point. So what you can do is you can what happens at the top when all of a sudden the slope is parallel to the x-axis? What is the slope of the line when it's going directly across? 0. So at the maximum value the slope equals 0. And then what happens? Bring over. Get t on its own. 45 equals 3t, and t equals 15. And if we go back to our graphical representation, where was the maximum value located? In between 14 and, which was 15. And if you read your table initially, you could see that was located at 15. Okay, so that's the end of that one there. Okay, now we're on to this one, part B. Lads, what happens is, okay, if you had a slab, the slabs are arranged to form a rectangular paved area. We can see that it's going across 40 each time, and down 20 because it's the shape of a rectangle, okay? Now, what happened was, if I said to you, what's the length of 3 slabs? I mean, the length going left to right. What would you tell me? 20. So you multiply 40 by whatever number of slabs you have. So this one says X slabs. That would mean the full length is 40X. And if I said how many slabs going down would 3 be worth? It'd be worth 60. Or 20 multiplied by the number of slabs. So that would be 20Y. Okay? Now, what is perimeter? Keywords, okay? Write the length of the perimeter in centimetres. Centimetres is another keyword. So what's perimeter?
4 sides.
4 sides added together, okay? So it's going to be 40x plus 40x plus 20y plus 20y. And what do we get in total? 80x plus 40y. Okay. The material being used for edging means that the perimeter has to be 64 metres. What's the significance of 64 metres in comparison to part 1 of the question?
It's 640 centimeters.
It's in centimetres. So you have to convert metres into centimetres. How do you convert metres into centimetres? Multiply by 100, and that will get me 6,400. The perimeter, which is this formula here, now equals 6,400. Now guys, what number will divide into all 3? 40. 80 divided by 40? 2. 40 divided by 40? 1y. And 640 divided by 40?
160.
160? Well done. Okay. Now, the question says y in terms of x. What does y in terms of x mean? Huh? Y equals something. Y on its own. Would 3y equals work? No, because it's not on its own. You have to divide by 3 then. So what we're looking at is getting y on its own. How do you get y on its own now? Bring the 2x over, okay? And what you get, y equals 160 minus 2x. Okay, so now you've successfully done part 2. Okay, now part 3 is a bit more difficult. Okay, we'll just skip that part for a second. Part 3. Find the value of x which the paved area is as large as possible. There's key words there. What are the key words? Find the value, but at the end, large as possible. Give me another word. Begins with M for as large as possible. Max. Once again, you're in differentiation. You've differentiated recently, so you understand this differentiation question. And what you're going to have to do is you're going to have to find out the slope equals what for a maximum.
Oh, the first derivative.
For a maximum, remember guys, it's an N-shaped curve, and what happens at the very top? Slope is 0, and the slope is the first derivative. Now, having all this information is great, but the first derivative of what? What formula? I don't understand. So, for example, we need other keywords. We did a perimeter question earlier. What question are we doing now? Paved area. So what you need to do is you need to redraw your diagram. Okay, from the start. This is 40x. This is 20y. What's the area? Length by width. It'll give you 800 xy. Area equals 800 xy. Now, we'd like to differentiate that, but can anybody tell me the problem with differentiating this? Sorry, does it? You've never differentiated anything with an x and a y together. You only ever differentiate something like this, wouldn't you? Like 800 x squared minus 40x. Something like that. Can anybody suggest a way of getting around that? We might have already done the work for this in a previous question. Which answer? Answer for part 2. And why did you say that now? Okay. The answer for part 2 has y in terms of x. So if we replace this y with 160 minus 2x, look what happens. What happens now to the equation? It only contains what letter? X's. Okay? Now, we're going to multiply this out. And what happens to A? What's 800 times 160?
128,000.
128,000 x, okay? X, yeah. And 800 times 1,600 x squared. Now, follow through of what we said earlier, okay? This is represented by an n-shaped function. If you were to draw this out on your calculator and plot it out, it looks something like this, where this is area, is the y function, and what's the x function? The x function is x, which is the number of, what's x defined as?
Slabs.
The number of slabs. So the more slabs you use, the bigger the area. Would that make sense?
Yeah.
That if you used 2 slabs, you have a fixed area. Then if you use, like, let's say 4 more slabs, your area is getting bigger. So as the x value goes up, the area goes up. But there's a problem. It goes up, and then all of a sudden, it starts going down. Is there any limit on how many slabs you're allowed to use?
Yeah.
In what part of the question did they mention a limit on how many slabs you could use?
64 meters.
Sorry, covered?
64 meters.
64 metre perimeter. That's why it actually goes up and goes down. Because the more slabs you put to the right, the less slabs you're allowed to use downwards. Do you understand? Because it's only allowed to be 64 metres in total. Now, so as we know, this equation here is a quadratic function. How do you know it's a quadratic function? X squared, right? Now that that's x squared, okay, what you can say now is it a U-shaped or N-shaped, even though I have it up already? N-shaped. Why? Negative x squared. And what did we say we're going to do to get the slope? How do you get the slope again? Huh?
Get first derivative.
First derivative. Let's do the first derivative. Okay, what's dA, sorry, what will be the letters for this, the first derivative?
X. Oh.
Let me show you now, right? If we have y equals x cubed, the derivative is dy dx. If I have s equals 3t squared, what's the derivative? ds dt. What do you think this one should be? The letter on the left over the letter on the right. So dA dx. And what's dA dx?
80x.
128,000
over 1600.
minus, now where does the 2 go?
3,200.
Minus 3,200x. And what do we say the slope has to equal to? 0. Now, this means that 3,200x, when we move it over to the left, equals 128,000. How do we find out what x is? Divide it. Divided by the 200, and what do we get? 40. Okay? Now, divided by 40. And what do we get? Oh, sorry, it is 40. 3,200, and x is 40. That means we're using 40 slabs. Now, can anybody tell me, what does this equation mean here? The one that's marked, circled in pink. What does A mean? Area. Area equals 128,000 multiplied by the number of slabs in the x direction, minus 1,600 multiplied by the number of slabs squared. How do we find this maximum area then? If we know there's 40 slabs,
Put in as x.
put 40 in as x, correct, okay, and this is going to answer part 4, which is going to be A equals 128,000x, 128,000 times 40 minus 1,600 times 40 squared. What's A therefore going to be equal to?
2,563,000.
Sorry? 200 and...
That's 200.
Is it though?
Yeah.
200 and...
Yeah.
No, okay, but...
Why is it?
Key question, is this in centimetres squared or metres squared?
Centimeters squared.
Centimetres squared, right? And what does it want it in? It doesn't say it wants the maximum, it just says find the number of slabs needed to pave. Oh, sorry. Excuse me, I just started getting a bit confused there actually. What I did was I found out the area of, I didn't find out how many slabs. We just had to find out the area of the full circle, yeah? The full rectangle. So technically we haven't answered the question, yeah? What we got is 2,560,000 centimeters squared. Now, if we find the area of one slab, then we can divide that in and figure out how many slabs we need. Technically speaking, we found out the full area. But if we find out the area of one slab, we can then see how many slabs it takes to fill up the full area. So how would you do that? It's going to be the area of one slab is 20 by 40. And what's 20 by 40? 800. Let's divide it by 800 and see what happens for the number of slabs. Number of slabs equals 3,200. Okay, guys.